Given question, find moment of inertia of given composite about centroidal axis by using parallel axis theorem.
In this question, we have to find out moment of inertia of the shaded area about centroidal axis. So first step is to find out the centroid for the given shape. We will follow step-by-step procedure. We will make parts into simple forms of shape such as right angle triangle, rectangle and semicircle. So we will make here one construction line. So if I draw one construction line, then this shape is in the form of rectangle. Now I will draw one vertical line, then here is the formation of two right angle triangles. Now we will give numbers to this shape. So this is the first shape, this is second shape, this rectangle is the third shape and here is the semicircle is the fourth shape. Now next step is to select x-axis and y-axis so that given shape will be in the first quadrant. So I will select this bottom horizontal line as a x-axis. And this vertical line as a y-axis. Now the point of intersection of x-axis and y-axis is known as origin. Now the values on the right hand side and values in the upward direction are positive. That means this shape is in the first quadrant and all the measurements are positive. Now to find out centroid, we will prepare one table. Now first column is for shape number. So we will write the first shape, that is the shape number 1. Now what is the area of the shape number 1? So area of triangle is half multiplied by base multiplied by height. So if we observe, base is 3 and height is 2. So here is area is 3 centimeter square. So area is in centimeter square. Now we have to find out value of x and y. For that we will follow step-by-step procedure. Now we have to first select the center point. So for this triangle we will select one center point. Now the horizontal distance, that is the distance from this height, is equal to 1 by 3 multiplied by base. 1 by 3 multiplied by base is 3. Now the distance from this base is also equal to 1 by 3 multiplied by height, that is 1 by 3 multiplied by 2. Now we will draw two perpendicular lines, that is on x-axis as well as y-axis from this centroid. So I will drop here one perpendicular line and this is the second perpendicular line. Now this horizontal line is known as x and this vertical line is known as y. Now we have to write the value of x. So how to write this? So 1 by 3 multiplied by 3, that is equal to 1. So this horizontal distance is 1. So if we observe, this total distance is 3. So 3 minus 1, that is equal to 2. So value of x is equal to 2. Now we will find out value of y. So here we have to find out this vertical distance. So if we observe, this distance 4 is given and after that the remaining distance is 1 by 3 multiplied by 2, that is 2 by 3. So we will write here 4 plus 2 by 3. So this is the value of y. Then we will calculate ax as well as ay. Now we will move to the shape number 2. Now we have to first select the center of this triangle. So we will select this point. Now its horizontal distance from the height is equal to 1 by 3 multiplied by base. So base is 5 centimeter. So 1 by 3 multiplied by 5, that is 5 by 3. Now it's a distance, vertical distance from this base is equal to 1 by 3 multiplied by height. So this height is 2 centimeters. So it is equal to 2 by 3. Now we have to drop two perpendicular lines. One is on x-axis, so I will drop here this perpendicular, and second is on y-axis. Now this horizontal distance from this center point is equal to x and this vertical distance is equal to y. So how to find out the value of x? So up to this point 3 centimeter measurement is given. So 3 plus 5 by 3 is the value of x. So I will write here 3 plus 5 by 3. Now how to calculate value of y? So here up to this horizontal line measurement is 4. So 4 plus 2 by 3. 4 plus 2 by 3. Now for the second shape we have to calculate area. So area is equal to half multiplied by base multiplied by height. So half and 2 is getting cancelled. So here area is 5 centimeter square. Now we will move to the shape number 3, which is in the form of rectangle. So first step is to select the center point. So this is the center point for this total height and this total base. So base is equal to 4 plus 2 plus 2, that is equal to 8. So we have to select the center point, and for this 4 also we have to select the center point. So now next step we have to draw two perpendicular lines. One is on x-axis and second is on y-axis. Now this horizontal distance is known as x and this vertical distance is known as y. So we will write for shape number 3, area 8 multiplied by 4, that is equal to 32. Value of x. So this x is the center point of this 8, that is 4. Value of y. This is the center point of this total height 4, that is equal to 2. Now we have to calculate ax as well as ay. Now we will move to the next. So next shape is the semicircle. So we have to give here shape number 4. So how to calculate area for this semicircle? So I will remove this previous construction. Now area, so area of circle is pi r square and area of semicircle is pi r square by 2, where r is 2 centimeters. So we can say that pi into 2 square divided by 2. So this is the area we have to calculate and we have to write here. Now we have to select the center point. So base is equal to 4 centimeters. So we will select here one center point, and after that with this vertical line this distance is equal to 4r by 3 pi. 4r by 3 pi, and here is the centroid. Now next step we have to draw two perpendicular lines. One is on x-axis and second is on y-axis. So this horizontal distance is known as value of x and this vertical distance is known as value of y. So how to calculate value of x? So here this is the center point of this 4, that is this distance is equal to 2 and remaining is 2. So value of x is equal to 4. And value of y is equal to 4r by 3 pi, that is 4 into 2, that is 8 by 3 pi. So we have to calculate 8 by 3 pi with the calculator and we have to write here. Coordinates of the centroid are x bar and y bar. So we will calculate x bar and y bar. So if we observe this column ax, then this is the value of a1 x1. Then for shape number 2 it is a2 x2, a3 x3 and a4 x4. Then area here is a1, a2, a3 and a4. So how to calculate x bar? So it is a1 x1 plus a2 x2 plus a3 x3 minus a4 x4 divided by a1 plus a2 plus a3 minus a4. Now why we are going to subtract the shape number 4 because we have to calculate centroid for the shaded area. So this semicircle is not shaded, which is the shape number 4. So when we calculate, then x bar is equal to 3.91. Now we will plot this point on the x-axis. So from this origin we will take point at a distance 3.91. Now we will calculate y bar. So for this ay, here this is the value of a1 y1, a2 y2, a3 y3 and a4 y4. So y bar is equal to a1 y1 plus a2 y2 plus a3 y3 minus a4 y4 divided by a1 plus a2 plus a3 minus a4. So y bar is equal to 2.83. So on y axis from this origin we have to plot the point 2.83. So we will plot here. Now from these 2 points we will draw construction line, and the point of intersection is known as centroid G. Now this horizontal distance from this y-axis is known as x bar, and the vertical distance from the x-axis is known as y bar. To find out moment of inertia by using parallel axis theorem, we have to prepare other table. First column is for shape number, and we have to show here the different shapes with respect to x-axis and y-axis. Area, value of x and value of y we have to take from the previous table. Now we will show here for shape number 1, that is the right angle triangle. Here is the centroid. Now from this centroid we will show x-axis and y-axis passing through this point. Now this x-axis is known as xc and y-axis is known as yc. We have to show centroid for this whole shape that we have calculated. So its coordinates x bar and y bar are known. Now this is the point, and we have to show the axis passing through this centroid, that is x1 and y1. Now we are going to use parallel axis theorem. So we have to first find out distance in between these two parallel axes. So if we observe yc and y1 are parallel to each other, so how to find out the difference in between this, that is yc y1 distance? In the same way we have to find out xc x1 distance, because these two axes are parallel to each other. Now if we observe for this shape number 1, this horizontal distance from this y-axis is known as x, and it is equal to 2. In the same way, for this point, the horizontal distance from y-axis is known as x bar, and it is equal to 3.91. So here is the distance in between yc and y1 is equal to x bar minus x, that is 3.91 minus 2, that is 1.91. So we have to mention here. In the same way we have to find out distance in between xc and x1. So how to find out? So here vertical distance, that is equal to y, 4.66, and for this centroid vertical distance from the x-axis is known as y bar, it is 2.83. So we will calculate this difference, 4.66 minus 2.83, which is equal to 1.83. Moment of inertia for the triangle shape along the axis xc is known as Ixc, and which is equal to bh cube by 36, where b is the base, which is equal to 3. H is the height, which is equal to 2. So 3 multiplied by 2 cube divided by 36 is equal to 0.66. Now the moment of inertia along yc is hb cube by 36, where h is the height, which is equal to 2, and b is the base, which is equal to 3. So it is equal to 1.5. Now we will move to the next shape. So next shape is also right angle triangle. So we will select here the centroid of the triangle. So we will show the axis passing through it, that is XC and YC. Now here is the centroid of the whole shape, and we will show the axis passing through it, that is equal to x1 and y1. Now we have to find out the distance in between this xc and x1 and yc and y1. We will calculate the distance in between y1 and yc. So for this yc and the distance in between this yc and y, that is the horizontal distance x, and distance in between this y1 and y, that is the horizontal distance x bar. So we will take the difference, 4.66 minus 3.91, which is equal to 0.75. So this is the distance in between y1 yc. So we will mention here. Now in the same way we will calculate distance in between xc and x1. So for this xc, the vertical distance from x is known as y, 4.66, and for this x1 and x vertical distance is y bar, 2.83. So 4.66 minus 2.83, which is equal to 1.83. By using the same formula, we will calculate the moment of inertia along xc and yc. So here is the answer. Now we will move to the shape number 3. So here also we have to show the centroid of the whole shape. So we will show the axis passing through that is x1 and y1. Now we will show centroid of this rectangle, that is the center point, and the axes are xc and vertical axis yc. Now we have to find out the parallel distance. So if we observe, we have to take the difference in between this horizontal distance x and x bar. So x is 4 minus 3.91. So we will calculate this. That is equal to 0.09. So we have to mention this. So this is the difference in between y1 yc. So 0.09. Now next we will calculate difference parallel distance xc and x1. So we have to take difference in between y and y bar. So it is 2.83 minus 2, that is 0.83. Now how to calculate the moment of inertia along xc and yc for rectangle. So for that we have formula Ixc is equal to BD cube by 12, where B is the base, it is 8 centimeter, D is this height, that is 4, and divided by 12. Now the moment of inertia along YC is dB cube by 12. So we have to put the value and calculate the answer. Now we will move to the semicircle. Now for semicircle we have to show the centroid of whole shape, and the axis passing through that is x1 y1. Now we have to show the centroid of semicircle. So it is also we have to show xc yc. Now by using the same formula we have to first calculate the distance in between y1 yc. So it is the difference in between x bar and x. So x is 4 and here is 3.91, and that is equal to 0.09. Now how to find out x1, difference in between x1 and xc. So it is the difference in between y bar and y. So 2.83 minus 0.84. 2.83 minus 0.84, which is equal to 1.99. So we have to mention here. Now for semicircle, moment of inertia along xc is 0.11 r raised to 4. So it is equal to 1.76, and along yc it is pi by 8 r raised to 4, where r is the radius and which is equal to 2 centimeters. So it is equal to 6.28. We will calculate moment of inertia of shaded area along centroidal axis x1, that is Ix1. So it is equal to Ixc1 plus area multiplied by xc(x1) square. So we have to write this information in this way. Plus for shape number 2, Ixc2 plus area multiplied by xc(x1) square plus Ixc3 plus area multiplied by this xc(x1) square. Now we have to subtract the shape number 4. So minus in bracket Ixc4 plus area multiplied by 0.09 square. So we have to show the curly bracket as well as square bracket. And then calculated answer is 91.45 centimeter raised to 4. Now we will calculate moment of inertia of the shaded area along centroidal axis y1. So we will take the reference of this table. So for shape number 1 we will write Iyc1, that is 1.5 plus area multiplied by ycy1 1.91 square plus 6.94 plus area 5 multiplied by 0.75 square plus 170.66 plus area 32 multiplied by 0.09 square minus 6.28 plus 6.28 multiplied by 1.99 square. So we have to show square bracket as well as curly bracket. So calculated answer is 161.96 centimeter raised to 4.